Alright, so what I've done is I've taken kind of a summary of all the different formulas and stuff you should have seen and you should have known from a trigonometric class or a trigonometry class, okay? So here's some things that I want to do. I want you to notice that there's a second Greek letter that we often use for letters. It's this symbol right here, which is pronounced phi, and then I also want you to know that sine squared of theta is really the same thing as sine of theta squared. So when you're evaluating, it helps you to look at the sine of theta and then square that value as opposed to this. So that's just notation that we're using here. And these are all things that you should have memorized. I'm not going to lie, most of you won't have all of these memorized, but there are certainly some of them that you absolutely need to know. Okay, the first one, and this is extremely important, that you know your Pythagorean theorems. You should know that sine squared plus cosine squared equals 1. What this comes from is a right triangle, and you're doing the opposite over hypotenuse, adjacent over hypotenuse. That's your x's and your y's, and this is your r's, really what it comes from. So it comes from a triangle. I don't really care that you know where it comes from. I just wanted to motivate for you. And then once you know sine squared plus cosine squared equals 1, if you divide everything by sine squared, you get the next identity, which is 1 plus tangent squared equals secant squared. And if you go back to sine squared plus cosine squared equals 1, and you divide everything by cosine squared, you end up with 1 plus cotangent squared theta equals cosecant squared theta. So sine squared plus cosine squared equals 1 is the one that you absolutely need memorized, and then you at least need to know how to get the other ones. What I do want to do to help you out is notice that tangent is with secant, and then cotangent is with cosecant. Notice I said the word co on both of those, okay? So cotangent, cosecant. So those are those ones for you. You should know the sum and difference formulas. What you really want to know is that you can evaluate sine of the sum or difference of two angles using single angles. So that's sine, cosine, cosine, sine. And cosine is cosine, cosine, sine, sine. But the idea is you've got to remember that you can separate them. Same thing with tangent. You can remember, so if you have something like tangent of 3 plus x, you can separate that into a different formula right there. So anytime you have a sum or difference on the inside of two angles, you can separate those angles. One thing that you're going to use in a Calculus 2 course without a doubt is the power reducing formulas. You have sine squared theta equals 1 minus cosine 2 theta over 2, and cosine squared theta is 1 plus cosine 2 theta over 2. Tangent squared theta is 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. So these power reducing formulas are extremely important when you're trying to find derivatives, or actually more important when you're trying to find antiderivatives, which is a study that you'll go into Calc 2, but I wanted to review it here so you just remember there are these formulas that take sine squared and puts it in terms of cosine to the first power, cosine squared is in terms of cosine to the first power, and tangent squared is in terms of cosine to the first power. That'll help you out. We did do some solving problems in trigonometry, which was law of cosines. Law of cosines was a squared equals b squared plus c squared minus 2bc cosine of a, where a is the angle. This is for non-right triangles, is when you use the law of cosines. Just remember, when it's a non-right triangle, you still can relate the sides and angles using the law of cosines and or the law of sines. Coming up in the next ones is the even and odd identities. These ones are really important for us as well. For instance, if I said, what's the sine of negative 30 degrees? Well, that's the exact same thing as negative sine of 30 degrees. That's called an odd function. In odd functions, you can bring the negative from the inside to the outside for trigonometric functions. If you notice, odd functions include sine of theta, tangent theta, cosecant of theta because that's the reciprocal of sine of theta, and cotangent of theta because that's the reciprocal of tangent of theta. So 4 functions are odd, meaning you can pull the negative out in front. Those would be sine, tangent, cosecant, and cotangent. 2 functions are even, which would be cosine. For instance, cosine of negative 45 degrees is the same thing as cosine of 45 degrees. So if it's a negative value on the inside, you can just make it positive. This is due to the symmetry of the function. You don't need to know why, but you do need to know that it is an even function. Even functions, you plug in the negatives, the same thing as plugging in the positive. So that helps you get rid of negatives for you. And again, cosine is related to secant. Secant is the reciprocal of cosine, so secant is also an even functions. Odd functions where you can bring it out in front is sine, tangent, cosecant, cotangent. Even functions where the negative becomes a positive is cosine and secant. Double angle formulas. Again, these are going to be formulas that you're really, truly going to use in a Calculus 2 course later on after this course, but I still wanted to review them. Whenever you have a double angle on the inside, so if you see that 2 theta, that's saying double the angle theta, you can actually change it into sine theta, cosine theta. Here's a cosine squared theta, or sine squared theta, or cosine squared theta minus sine theta. This one's really, this cosine 2 theta, this double angle for cosine theta, can be used for multiple reasons. You are going to see something like, oh, they want you to take the derivative of, or antiderivative of, this 2 cosine squared theta minus 1, and it's a lot easier to take the derivative or antiderivative of cosine of 2 theta. So you're going to go back and forth between these forms. There's also a double angle for tangent of theta, and it's there. Again, are you going to memorize all of these? Look, probably not, but you do need to when your teacher says, hey, do you remember there's a double angle formula? Oh yeah. So this is a page that you might want to print and keep in your folder for when you go on to a Calculus 2 course as well, just to review. So when your teacher asks, hey, have you seen these? Do you know about these? And you should say yes. Certainly the reciprocal identities and the quotient identities you should know. Remember, cosecant theta relates to sine theta. It's the reciprocal, so just flip sine of theta. That's cosecant. Secant relates to cosine of theta. Secant is the reciprocal of cosine theta. Just flip it. And cotangent is related to tangent of theta. So you're just going to do the reciprocal of tangent. You're just going to flip it over. Okay? These are hugely important because, for instance, if I said what's the sine of 30 degrees, you could put that directly into your calculator. If I said what's the cosecant of 30 degrees, there isn't a cosecant button on our calculator, but you could put in your calculator 1 over sine of 30 degrees. Same thing with secant. If I said what's the secant of 45 degrees, you'd put 1 over cosine of 45 degrees in your calculator. What's the cotangent of pi over 2? You'd put 1 over the tangent of pi over 2 in your calculator. You do need to be careful with these, though, because there's going to be some places where the cosecant, secant, and cotangent functions are undefined. For instance, anytime sine of theta is equal to 0, cosine of theta is equal to 0, or tangent theta is equal to 0, each one of these fractions would be undefined because you'd be division by 0. So anytime one of those original sine, cosine, or tangent is 0, you have your reciprocal functions are undefined. You should also know that tangent theta, which was opposite over adjacent, is the same thing as sine over cosine. So tangent is sine over cosine, and cotangent is cosine over sine. Those are hugely important for you to know. Anytime you're dealing with tangent, if we want to find the derivative of tangent or antiderivative of tangent, many times it helps you to look at it as sine over cosine, at least until you learn the rules. So you're going to change tangents into sines and cosines, cotangents into cosines and sines. Little thing that helps me memorize this is I remember that co and co go on top. So for cotangent, you have the co on top. The c's are on top. Okay, and then that helps me memorize that tangent is sine over cosine, so I can remember which order it is.